Hi students, in this video we are going to discuss about path length. So today our concept is path length. This path length we also called as distance. Once again, today our concept is path length. The path length we also called as distance. Now here go for some. I would like to give an example about path length in the form of numerical. Then we can easy to understand. Take it is minus 160 minus 120 minus 80 minus 40 0 40 80 80. Now once again I am repeating minus 160 minus 120 minus 80 minus 40 0 plus 40 plus 80 plus 120 plus 160 plus 200 plus 240 plus 240. Next plus 280. After that 320. After that 360. Once again I am repeating the numbers. Minus 160 minus 120 minus 120 minus 80 minus 40 0 40 80 120 160 200 240 280 320 360. Now these are the intervals. Here consider minus 120 as capital R. It is a number. Here minus 120 is a number. Here consider that point is R. Consider 0 as 0 and consider 240 as Q, alphabet Q. Consider 360 as P. 360 as P. Now here to describe motion along to describe motion along a straight line motion along straight line motion along straight line. Choose an axis minus x and choose an origin. Choose an origin. Choose an origin O. Once again, to describe motion along a straight line, choose an axis X. Choose an axis X. Choose an origin O. Then we can easy to understand. O. Now, position of the right position of the right of origin O are taken as positive. Taken as positive and to the left of O as negative. Now, the position coordinates of Q and P are 250 meters. The position Q and P are 250 meters and 360 meters. Next, the position of coordinate of point R is minus 120 meters. Once again, the position of coordinate of point R is minus 120 meters. Consider the motion of a car along A straight line. Along a straight line. The car started it. The car started. The car started. Yet x is equal to 0, comma, time t is equal to 0. Let p comma q comma r represent the position of the position of the position of the car. The position of the car, yet different instant. At different instants of time. Full stop. Now here we are going to discuss case wise. Once again I am repeating this point. Let P comma Q comma R represent the position of the car at a different instant of time. Now here case 1. Case 1. The car moves. The car moves. The car moves from O to P. Then the distance. Then the distance moved. Then the distance moved by the car is OP. That is equal plus 360 meters. Once again, the car moves from O to P. Then the distance moved by the car is OP. That is equal to 360 meters. This distance is called the path length. The distance is called path length traveled by the car. Once again, the car moves from O to P. Then the distance moved by the car is OP. That is equal to 360 meters. This distance is called path length traveled by the car or distance. Now, case 2. The car moves The car moves. The car moves from O to P. The car moves from O to P. The car moves from O to P. And then moves back from P to Q. Moves back from P to Q. During this movement, during this motion, the path length travel the path length transferred is OP plus PQ, that is equal to 360 meters plus 120 meters. Now, how much we will get? That is 480 meters. Once again, the car moves from O to P and then moves back from P to Q. During this motion, the path length or distance traveled is called OP plus PQ. That is equal 360 meters plus 120 meters. That is equal 480 meters. Now, note, path length is a scalar quantity. Path length is a scalar quantity, or the path length we also call as path length. We also called as distance. Next, the path difference. The path follows between 2 points. Is called, the path follows between 2 points is called path length. Slash distance. It is always, it is always positive. That means now take, it is point A, it is point B. From A to B we called as path length. The path length is a scalar quantity. The path length we also called as distance. The path followed between 2 points is called path length or distance. It is always positive. Okay, this is about path length. Now go to next point. Note, note, a quality, a quality that has a magnitude only and no direction and has no direction is called scalar. A quantity that has only magnitude but no direction is called scalar. Now, displacement. Now, displacement. The change of position. The change of position is called displacement. Now, once again, the change of position is called displacement. Let x1 and x2 and x2 be the position of an object at a time t1 and t2. Then its displacement denoted by delta x. In time delta t, now delta t is equal to T2 minus T1 is given by the difference between the final and initial position. Final and initial positions. Final and initial positions. Now, delta x is equal to x2 minus x1 if x2 greater than x1, then delta x is positive. If x2 less than x1, then delta x is negative. Therefore, displacement has both magnitude and direction. So it is a vector. Now another definition is also there. The shortest distance between two points. The shortest distance between 2 points is called displacement. Therefore, consider it is A, it is B. The shortest distance between 2 points is called displacement. It is either positive direction, it is either negative direction. The displacement is always 1 between 2 points, whereas the distance is so many paths between 2 points. Once again, the distance is always only 1 between 2 points. Note, motion along a straight line called rectilinear motion. Rectilinear motion. Once again, motion along a straight line is called rectilinear motion. Next, in one-dimensional motion, there are in one-dimensional motion there are only two directions. Two directions. There are only two directions. That is backward and forward or upward and downward, upward and downward. In which object can move, object can move. These two directions can easily be specified by plus and minus sign. Once again, I am repeating this point. Motion along a straight line is called rectilinear motion. In one-dimensional motion, there are only two directions, backward and forward or upward and downward, in which object can move. These two directions can easily be specified by positive and negative signs. Now, example. Displacement. Displacement of car. Displacement of car is moving from O to P, is delta x, that is equal x2 minus x1, that is equal plus 360 meters minus 0 meters, that is equal plus 360 meters. Now, in this video, we discuss about distance and introduction of displacement. Now, next video, we can elaborate about displacement. However, thank you very much for watching this video. Thank you.